Hello, my name is Marlene. I'm a master's student in earth science at the National Autonomous University of Mexico. And my project is titled 3D Rockfall Simulation Model using Terrestrial LiDAR in the active Pajacuaran Fault, Mexico. First of all, I'll give some brief context. In Mexico, during hurricane season, mountain regions are affected by rainfall-induced landslides on a yearly basis. A clear example is the case study of the Pajacuaran Fault, where an intense rockfall event took place during the beginning of November 2013. The high precipitation regime, the local seismic activity, and the rugged topography, as well as the lack of a proper urban development plan, are only some of the factors that contribute to the rockfall hazard in this area. That said, the purpose of this investigation is to evaluate the potential rockfall threat throughout a portion of the active Pajacuaran Fault. In order to ensure relevant results, the following workflow was completed. For a local scale of 1 to 10,000, it can be divided into 6 phases. Preparation involves reviewing all the records on historical rockfall events. In our case, the only registered event is that of November 2013, in which we were able to know the date, the precise location, that is, start and deposit point, and the size of the fallen rock, giving us an overview on the magnitude of rockfall events. Also, it is crucial to carry out a field study to characterize and map the release zone, the transit zone, and the deposit zone on the slope. A major part of our fieldwork was through terrestrial LiDAR surveying. We performed a total of 6 scans and acquired coordinates of more than 135 million points along the Pajacuaran Fault, including 4 rock faces in the release area. In the transit and deposit zones, we conducted a detailed rockfall inventory and recorded the slope surface characteristics. The forest characteristics were also inventoried and mapped. Next, it was necessary to prepare the input data for the rockfall simulation. This included processing the point clouds to produce a 1-meter resolution DEM that defined the topography of the slope. Furthermore, it involved creating polygon maps and exporting the data in the correct format. The release scenario definition deals with defining which rock size might fall from which release area. Combined with point cloud analysis, the deposited rocks allowed us to define the shape and the dimensions of the blocks. In addition, a slope threshold value of more than 55 degrees was applied to determine the potential rockfall release zone. For the rockfall simulation, we used Rocky for 3D, a software model that simulates the trajectories of falling rocks as 3D vector data by calculating sequences of parabolic freefall and rebounds on the slope surface, as well as impacts against trees if that is required. The input data consists of a set of rasters in ASCII grid format, which define the topography and the slope surface characteristics, along with the release conditions. If you are considering rockfall nets or forests, a set of raster maps should also be created for this data. All output can be directly opened and visualized in most GIS software. Plausibility check and validation. The simulation was repeated with slight modifications of sensitive parameters. This phase concluded when the results produced by the simulation model finally corresponded to the stopping positions of the rocks inventoried in the field and the actual rockfall path from the event of November 2013. The fixation of model results consists of defining an area as the valid runout zone, and finally, transformation into rockfall process maps. By applying rockfall for 3D, we were able to determine the breach probabilities and delineate the rockfall runout zones along a hazardous portion of the Pajacuaran Fault. Furthermore, the output rasters corresponding to the kinetic energy, passing height, and velocity are convenient sources when the final intent is to design a protective barrier. Ultimately, these results provide useful information to predict the rockfall hazard and create zone maps. Our findings can be useful to authorities in charge of decision-making with regards to disaster prevention and mitigation, as well as to aid in the regulation of future expansion in these hazardous settings. Thank you so much for listening.